expect to get with color and but this is a little down from the measuring as process harvest range.
Associated with our
Hello everyone, my name is Ella and I am Business Development of SPS Engineering.
Good morning everyone, my name is Dodi, so SPS team in Okay, my name is Dindra, the same position of my colleagues in the University Civil Engineering. Thank you.
Then there should be enough time for those people, if they want, to go and look at what was looked at the first day, which is the large river protection, restoration. But please, it's low tide, right? So when you're looking at it, imagine that there's water in there. Right. It's in the dry season. So it's designed for the wet season right now. Please do not be discouraged when you see the base of the river. That's not what it looks like when there's water in there. Okay. So that's the
Indigenous peoples who live in third world conditions, even though they live in a first world nation. Thank you very much for that.
To the system, but I think in business often there's several things that are important to underlie business, and one of those is picking and seeing mega trends that are going on globally. And in the Pacific, whereas mentioned before, there are key issues facing the Pacific: climate change, islands becoming uninhabitable, just the general issue of the cost of electricity. Because when it comes back to it, electricity underpins just about everything in a community, from lifestyle, air conditioning, from safety, from health, lighting, security, right through to creating a cold chain for economic development, whether it's tourism or fishing or whatever. So at its heart, pretty much any economic development across the Pacific is going to be reliable sources of electricity. The sources of electricity, the existing infrastructure in a way that we can provide cost-effective power, is very interesting and exciting to us. From an economic point of view, we can produce electricity for between 4 and 10 cents to offset otherwise the cost $1 plus. That has economic benefit, but it also has community benefit. So we're very interested in working from the ground up with this system and taking the opportunities that are presented in those percentage of use cases where there's constantly flowing water or sufficiently deep water for us to work. But at its heart, it's about creating a business which has spin-off benefits for the community as well.
about goals 6 and 9. What can we do where there's water, and what can we do where there's infrastructure and innovation to help create a sustainable and more particularly regenerative economy, well, not just an economy, but across 4 dimensions. And as Leonard has said, one of the things that's impressive about Yeoman's technology is the ability to link it into the dimensions of economic, social, ecology, and one more, spiritual. And so the ability to have different cultures using as a means of promoting those 4 things is what attracted me to it. So our purpose is to further those 2 goals onto the sustainability world, the SDGs.
We're quite busy actually, from last yesterday to today, so I expect to prepare a bit better, but hopefully probably not here. So we try to provide engineering thing right now regarding to SPS. SPS is modular panel, actually, complete panel, and they call as existing panels, which means multiple uses for multiple use from made of concrete, which is precast concrete. So technically, we try to provide a stiffness of a structure. Actually, if you look at the basic structure, but the thing is, we fill another material, which is the soil itself, which means another stiffness we provide more. The thing is, when we calculate like this thing, actually the load coming from the lateral load, which is coming from outside, from the horizontal one, to bring to the structure, which means we have the structure to resist lateral loading or horizontal loading. That's the main point. But before that, if we have a frame, actually we already have a structure. Now the interaction between those the soil and the structure itself, and another more right now is the water. That's the interaction which is bring more complicated. Thanks, we've got the software from European, from America, from Australia. I think quite massive help for us to explore more about the interaction between the structure itself. So right now, the main point is if we have a practical load, actually to provide better solution if we have a lateral load, which means this is a gravity load actually. We have a bit more loading to the ground, and then the lateral load, which is much more easy to resist it by the structure. That's the main point of this one. Now, technically, if we close a bit more regarding to the foundation, regarding to how the deformation we've got, that's a different way to look at it. And then sometimes we provided another material like what we got here from Lorry. We got into another material like a synthetic material to bring in, like geo-tech style, another material to provide the strength, shear strength to the soil, and it would bring another resistance to be here. That's belong to the different cases. Any cases what I mean is, if we put this structure to some problem, probably we provide another solution. It is not massive or typical analysis to bring all the structure, which means if we have a case and then we try to provide another analysis or a proper or a suitable analysis into that kind of cases, that's the main point actually, because the soil itself, the local soil, the strength of the soil is should be different from another to an area to another one. So in Indonesia, actually, we talk about earthquake a bit more. We're concerned about this thing because very destructive hazard loading to our country. That is the good way we look at a bit more regarding to the lateral loading, because the shaking load like earthquake is much more destructive to the structure. Even worse if the structure is higher, make more higher than we expect. Now for this one, it's quite probably if I get as I said about quite easy to check regarding the load. It's not bring it more than 5 meter, 6 meter. But right now we've got a project like 22 meter high of the structure, and then we put transportation load like a truck loading at above here. Above the structure. So it's a challenge for us. How the SPS from Anggara will bring reliable structure, because sometimes it challenges for us how to solve the analysis. Sometimes it works, sometimes it's not working. That's a good point for us in order to find a good solution, because it's not easy to use whatever the case is. It's not like that. But so we bring it like, I'm very sorry, my slide in Bahasa, still in Bahasa. For example, here we have a safety factor. That's it, the availability of the structure, which means the capacity of structure. It's represented by a safety factor. The requirement of safety factor for retaining wall, for example, we just provide 1.5. That's it. A bit more than will bring us to costly. I mean, it should be more expensive than we expect. So if we use another safety factor or limited safety factor, it's a different solution. A bigger safety factor we provided, of course, we have a convinced structure. So let's move what we've got here. Now, technically, yeah. Yes.
If people have got any questions, you don't sort of lose the translation. But also, we will get this translated, and if you're okay, if I can translate.
So is there any questions at this?
Overall stability of the structure.
Overall stability.
Overall,
Yeah. Okay. Let me bring to more general language. Probably I'm very sure. Oh, sorry about this thing. If we have the structure, the capacity of structure. Let's see. If I stand here, and somebody move out from outside, from the other side, I will try to resist that load. That's the main point. If big guy coming from us and then I will collapse, then I try to resist that load. That's as simple as that. So how can I resist Alan moving to me? And then that's my capability or my capacity. That's we bring it the number here, which is like a standard, like a requirement to bring it to the structure.
thank you for that. The SF rating.
Sure, yeah. That's a good point, because if I will look at another product will come in if we apply it to this structure, and then another advanced material, another advanced collaboration like the analysis as well. We have to that another opportunity to bring into this structure, which means if we want to increase this one, hopefully it's not bring it more costly. I'm very sorry. We expect we've got a better capacity, better safety factor, but hopefully we just stay at that cost. I mean, it's not expensive than we expect. So hopefully, good material coming to this structure. Hopefully not increase the cost. Actually, that's a good point as well. So we apply this kind of a system with the solution in the cost as well, in the social as well, as Alan said. For example, right now in Bali, we try to provide the solution to, as a breakwater, for example, we didn't expect to get a boulder from the natural resources. That's we found right now it's limited, and it's no more big boulder to be put along the coast, because there's no provided and it's not available. So we try to bring this one probably as a solution, and then we try have we've got the study as well to this thing, and then we can share. I will bring to Alan, to anybody from this study last time, probably 2-3 months ago, on the lab. So I didn't bring right now, and then we'll expect to share later.
So what I'm hearing out of that is the answer is yes.
So yeah.
But it comes at a cost.
Yeah, it comes to the cost. If the cost would be controlled, we need to control the cost. Surely, if we put advanced material, sometimes we get beyond the cost, and so it must be probably it's not quite a good solution. So I think so. Yeah.
So on the same subject, so the SF rating,
what would that typically be for a gave-on or a sheet pile structure? What rating would they be achieving in a traditional installation?
Yeah, if we compare, you said the comparison.
Yes. So if you have a gave-on structure from 10 years ago in Bali, so what rating would they have achieved or claimed originally?
Okay, that's a great question, because we try to provide a different solution from the existing one. Is it right? Yeah. The existing one, sometimes they have a limitation. Like I said before, if we find limited resources to be put as a retaining wall, and then we try this solution. And then sometimes, by the case, the structure will be in the risky one.
Yes.
For example, at the slope, really steep slope of the soil, and then if we put the kind of typical gravity structure, and then it will be not working properly as the engineering requirement. That's probably the background. If this structure will be put, then that's provide a solution for this thing.
So like less than 1?
Oh,
This for a gave-on structure is an example? More than 1? 1.5? What's?
If we compare, let us say, the apple to apple, it's probably the safety factor probably quite the same, and then we just compare probably the cost. We just compare with the construction method, like it's much easier to be put, and then probably less time to build. Probably it's a good solution for engineering as well.
Anybody else? Before we continue?
I think I try to add, because this my guys is really expert for soil things, because this structure is depend on the soil interaction. The existing soil is bring the structure will behave differently. I mean, really on the soil. So the safety factor is that, like, if we provide a same safety factor, probably will give you compare with the SPS. We've got probably the same asset. However, we have a lighter structure. We have more reliable structure, like the stiffness itself. I mean, sometimes if the water will be cross or transport from this side to the other side, it's a different way. It's a different analysis. Let's say the gabion is easy intrusion, water intrusion is good enough, but in here, if we want to protect the water coming in across to this side, this will be more help than the other. So it's depend on the case. We didn't expect all the case it will be SPS solution. No, not really. But this one is better for. We try to compare this one with one apple to apple, and then sometimes it's work better. Sometimes it's probably this is expensive. Probably we get a bit to be choose another one. If this system is more more expensive. Yeah. So yeah.
To try and compare the two is difficult. A Gabion structure, which would have the same safety factor, might have twice as much bulk. So you can't just look at one against the other without looking at what's going in behind it. For a pile or a sheet pile structure is quite different again, where the piles might have to go, say, if we're going perhaps 1.5 metres into the ground, the piles might have to go 5 metres into the ground to obtain the cantilever effect that they produce when you're back from arguing against them. They're very difficult to do a straight comparison, I believe. You can do it obviously, but what we're doing here is so simple compared to the other structures. The Gabion structure takes probably a lot longer, I would think, because you've got to carefully place the stones within the cage. In fact, we climbed over a Gabion structure yesterday, I think, supporting some of the upper embankment. It's been there for some time, but not down at the lower level. So it's a difficult comparison to make. You've got to look at all aspects. I'm surprised that the safety factor is only 1.5 to 1.7, because the engineers I work with are probably 3 times that, and they're very cautious.
You said about the Gabion, how do the Gabion work? It's really cannot compare easily, and then all an aspect to be good one. But Alan said about a good point, because this system provides concrete material, which is the precast one, and then the durability of the material itself is quite better than the others. For example, let's say the cage of the Gabion said about 15 years as the durability of the material, and then the corrosion come up, and then the Gabion probably is not working at the hazard water, like chemical sometimes, but hopefully this one, because they have a deck, let's say a cover, concrete cover, that's a probably better solution for hazard environment. So it's better for that one as well. So a longer durability of the material, it's probably take time, and then of course if you compare with the cost, that would be, let's say the investment in front initially, it's quite cost a little bit, but if the longer structure to be as a durable structure, this will be longer. It's probably a good solution for the cost as well. Is that good for you?
Continue. Unless there's any more questions.
To get a bit color. But this is actually a very thing to bring us how the strength, how this the stress working inside of the structure. So we try to deep in what Mr. Angara to bring us the challenge was this like this. And this is not working, and we didn't expect to be bring for you this thing, right? So we try to get inside of the structure. Color provided the stress at the pre-bar, at the concrete itself. So this is bring us confidence for the structure. So I think it's a good opinion for now. Now, if we compare something else, this is technical comparison before we do with the economical thing like the cost and everything. So if last time we have a different structure, which is using a conventional retaining wall, using a concrete and then the pile itself. So it's the method is really hard, and then the cost is quite not. Sometimes it's much more expensive. And that's why SPS is suitable for this kind of structure or the problem there. So this is the route. The main route will be along that side perpendicular to the plane, and then this is the structure. If we have a good solution for additional land to be built, and then it's a good solution for the social as well. So I think this is the main structure as SPS. So it's worked up to now. That's the good point as well. So only right now in Indonesia, they try to get a specific what we call a standard. they try to provide the standard for SPS right now. I mean, the SPS team tried to contact the authority to provide the specification in order to bring the SPS to be constructed all over Indonesian area. In order they got the standard or sign or stamp from the government. If they got, I think we consultation already there. It means we just to provide the monitoring or control of the structure. I mean the previous structure or the structure installed last. I mean the previous structure, and then we try to provide control monitoring. The result of monitoring we need to provide to the government, and they will stamp for that one, and then the government asks for the audience in, the industrial Indonesia to bring it into a solution for everyone in Indonesia. It's not local in Bali, but probably they bring to all over in the Indonesia area. So I think it's a good point. But what about a this is the case again. I'm very sorry for probably you look at this one. That's better language for you probably. We have analysis or publication regarding the effect of variation of thickness and the shape of precast concrete panel for returning wall is of the river. Of the river is good point for us. This kind of structure try to put on the river bank. Actually, this is the river wide, about 20 meter wide, and then we change this kind of structure. This is the existing structure to be put, and then we try to provide another solution like SPS 1. So this is the comparison between the structure.
Structure, as you've seen in this Ali's slides, it's just like a hollow. Can you? Yes. No, I mean show that the structure. It just looks like a hollow because some panels and truss and cables and everything over there. So what is inside that system? We need soil. So soil will be filled in, soil material, any soil material will be filled in into that system, into the, shall we call it chamber, small chamber over there, in that body yang So what is inside the system? It cannot be just empty like this, so we need to put soils or any material. That's a selected one will be good, but we try to find the most. We can use any soils. So just surrounding the area, the site, so we can use that as long as we have. Actually, we have some projects back then in 2015. So first time when Anggara recruited me in this system, and we have a proving ground in Karawang Regency in West Java. We try to normalize the river bank. There's a problem over there. We have a very, very soft soil over there. So we need to put the system on that soil. So we need to know what is the bearing capacity, the minimum bearing capacity of the soils over there. So we can put that system on top of the soil. So we need to exercise that one as well. So we talk about settlements. When we put this system on the soil layers, probably someday there will be a settlement. We cannot guarantee that system will sit on top of that and there's no movement vertically or to the other direction, so X, Y, Z. When we talk 3D, we have thoughts about Z, X, and Y. So there probably a movement in that direction. So we need to know about that as well. So this system, when we talk about structure, I think my colleague Padi is already explained everything, and he's the man who knows everything, the tiniest thing about this system. You can ask him. So in other point of view, when we talk about geotechnical engineering, so that support this structure, so we need to know the sufficient bearing capacity of the soil that structure will be sit on. So that's the additional things that we need to consider. And about the fill-in material, we have. Yep.
Will you make sure I understand what you're saying?
Do other things rather than make it wider. So we try to improve the soil layer, put geogrids, put piles and everything. So that can be done, so that we don't have.
So your solution will probably be an economic decision.
Exactly right. So other things about the key issue in this panel system, that we need to compact the soil inside the box. The compaction is very, very critical because it's going to be to give the weight of the total structure and also to try to make it intact. Because this cross section will be in the long section to that direction, so we need to make sure that the weight of this block is similar, it's uniform along the section, the long section. Right? So it keeps the stiffness of this long section, so it will provide the tilt of it and also the differential settlements to this area, to this direction or to this direction. So we need to make sure also about the compaction inside the box. So other thing is also we need to check all this work. I mean the compaction work with the laboratory exercise in the laboratory, and then compared to the what we have in
together, and the soil changes underneath. How do you keep the rigidity so that it doesn't drop in one place and it's just all the way solid?
First of all, we need to this structure will be sit on it, so we know which part will have enough or sufficient bearing capacity, and which part is need to be improved to get the same bearing capacity. So we need to know about that first, and then we can do action. So let's say in some part we have a very low bearing capacity, we do the improvement.
Another material like the soil itself is bring us a bigger strength after compaction. Layer per layer, compaction is provide us more convenient stiffness and shear strength of the structure, as my colleague said last time. Bearing capacity and shear capacity of the structure will be bringing more confident structure. That's a good point for us. And then again, if we try to provide analysis like we call right now as the soil structure interaction. I mean the interaction between the soil and the structure. That's a good point for us. But now again, we have a fluid structure interaction. So we have treating soil, fluid, and the structure itself made of concrete. That's a good point for us to look at this kind of structure as a challenge to us to bring more. And then another interaction is coming from the flood, like the fluid interaction. We have a different stage construction scenario, which is case by case. We try to provide analysis as we bring it like this one. So first step, for example, using a gravity one, how they try to put the excavation, they try to fill the structure in compaction up to the total structure set up totally, and then bring additional load here, how it will be work, and then how the structure perform, and then we will look at the behavior of the structure under the extreme load. For example, the extreme load what we expect, like the flooding there, and then another flood from outside itself. Of course, we include the additional load, for example, the transportation load or truck and everything. So the good point here is we try to work using a stage construction, stage between step-by-step construction when we using this kind of structure. We'll start from when we dig the soil, and then we check the bearing capacity of the soil, and then the solution probably using synthetic material, and then wherever work with the soil, and then we bring the panel, we bring the print and everything step by step. So we call this stage analysis here. For example, with empty, what about in empty soil there? Which means if we dig or we make an excavation, what about the soil here? How the interaction of the surrounding, for example, if we take out the soil, for example, here, and then we have analysis there, which means the risk we expect to find here, probably we need to provide additional retaining there before complete structure to be set. That's a point here. So we have to bring there as well the safety factor per stage. I mean, the first stage we provide, for example, gravity load there. Here, the first one, if we look at the gravity loading, the safety factor provided is 1.4 or something, and set the factor from stage 1, which is the existing condition. We have almost 2 there, and then condition where we do with excavation, first excavation, second excavation, we provide a safety factor like 2 or something, and then the other if the whole panel to be put, and then we bring it safety factor again, so like that 2, and then another loading to be put there, we still have a 2 point something as safety factor, and then if we have another scenario, I mean the last scenario there, which is using loading there, and then increasing water, which means the flood over there, and then we still have a safety factor quite convinced, which is more than 1.1. That's a technical analysis. We bring it to the audience in order to know a bit more how the performance of the structure. And then probably next time, because I'm expecting a result from laboratory test. We're using wave, tidal energy, tidal loading to the structure. That's we expect to be a bit more presentation for this one. So, and last time I tried to provide analysis itself. So regarding to (22 meter), the problem is not relating to the structure, but we've got a problem with the soil. Actually, we expect. This looks like this one. The color itself is not. It's really annoying, which means this analysis the blue color, which is it's not movement there. But if you look at the number there, which is beyond we expect. I mean, this is the worst is deformation over there. So where is that come from? It will be here. So if you look at closer, look, that will be here. The number, big number here. I mean, it's really big number. It's in progress. It's not in the SPS. That's we bring our solution, and then this is a different solution because the solution is this is the road actually. I mean, our main road, national road, highway actually. We try to provide. Support structure, which is using pile, for example, because I just don't want a problem to the structure. Let's put that one into the structure, which means not all problem will be solved by the SPS, and then this is bring another material, another structure. For example, I just would like to have another one material, for example, another one technology. And then this one, because the case is this layer of soil, the stratification of soil, as I said, my colleagues here, it's really soft soil. And then we didn't bring the contact structure here, and then we try to improve the structure underneath of the soil underneath of the structure, and then we try to introduce pile layer in order to bring reliability of vertical and then also upload. This is the solution for this one. Hopefully it will be working up to 40 years. That's we expect, and then our government try to provide a good reliant structure in our country here. So please bring us
debris from the water, but to avoid corrosion, because the steel is
okay.
not getting any water, and then there's the inside of the box.
What I mean is, if the steel here would be protected by the cover, of course. Yeah, I mean the water here, the water will be intrusion from underneath of the structure should be natural one. Of course, the water will be trapped inside of the structure. That's what I mean. But we didn't expect the water will be will be hazard to the structure. I mean, if we put the steel there, the steel itself is protected by the cover.
Yes.
Cover.
Gravity.
Yeah, which means at least for the hazard environment would be 7 cm, 7 centimeter. What I mean would be used into the structure. But for example, here, the water itself using weight, half a weight, of course. It's good for the structure itself, but of course we didn't expect if the water transport here, for example the water here, and then flow to that side, we didn't expect the material layers will be coming out from the structure. That's we protect, we have to protect the material inside of the structure. Please. So, yeah.
And total waterproofing. And that's a question that Alan asked. So are you saying that the structure, to maintain its integrity and its stability, some water is permitted to flow through the structure, provided that the material inside does not leak out? That's what you're saying?
Yes.
Thank
Yes. Very clear. I'm very sorry my explanation is not good as you.
A supplementary to that, if it doesn't flow out, what about under? What about that?
Okay, are you saying tilted up structures here?
If it's compacted soil inside,
Yeah.
what do you do with the base? If there's water in there, why doesn't the soil
Okay.
come out the bottom.
Yeah, because last time in our project said about protection. You see here, we have synthetic material to be put, providing the bearing capacity, additional bearing capacity, and we put another one, a geo-tech style one, which is a very tiny material of soil. We protect it from the penetration or permeability system of the water. So the leaking out will be avoided by the geotextile. That's why we use sometimes two material. The base at sometimes others puts all the perimeter of the structure. We protect the material leaking or material coming out. So another one solution in order to provide bearing capacity. That's all together. Yeah, provide better bearing capacity as well as to protect material coming out using geotextile. That's good.
So I think.
Hello?
Yeah. Right. Yeah. Or if you want water protection or like waterproof, probably we can do that, but probably very.
It's not necessary.
It's not necessary. Sorry.
And it even becomes somewhat superfluous if we start using masonite instead of steel.
Yeah. Yeah. We have to cover the steel.
Yeah.
To check corrosion.
Yeah, that's correct.
Further to that question about the base, the textile material at the base of the structure is than the textile material, or is it designed for the textile material to be pliable to mold into the surface where it sits?
Sometimes yes. We probably, if we use technically we can use a stiffness slab, for example, which is a stiff material. We can do that. Probably much better. The thing is, if we provide geotextile one, it's a product. They provide tensile strength, really provide a shear strength to the structure, which means this structure will be sinking actually, but this material will protect from sinking because they have a tension strength. That's good.
So there is some opportunity for different designs of the base. For example, if you had a corrugated base, you increase the surface adhesion to the base, and you increase the integrity laterally and longitudinally.
Yeah, I think it's a good point for us right now. You bring us a different idea, and then you can improve the structure by using.
We patented that incidentally.
Really, so.
Issues about the base of the structure. So when water flow to the base of the water, it's a doomsday. It's gone. Yeah. Everything will be gone. And we have this experience when we worked in 2015 in Karawang, West Java. We have this kind of problem. So what should we do? We try to protect. So let not the water flow into. How? We put another structure. Can we put another structure when the situation is very, very specific or unique? When the water flow to the base, we have an uplift pressure over here. We have a lateral force because of the water. So there will be an additional force that might destroy this structure. So we try to keep this force, and then we try to do something else and put another structures, or maybe put another improvement to the soil to prevent the water flow on the base of this structure. What about the inside one? the water may flow over the structure. When you put this structure down beneath the water table or water surface, the water will be flow on the top of this structure. How to prevent the water not penetrate into this segment here? We do the compaction. As I said before, the compaction is not only increase the weight of the soil here, but also reduce the hydraulic conductivity of the soil. It means that when we reduce the hydraulic conductivity of the soil, the chance for the soil to penetrate into the soil is less. So that's how we provide. There will be no additional water, or at least we can reduce the water penetrate into the this hollow. So that's how we work on it. And what about when the water come out? Because we have probably we still have not a watertight structure here. The water may flow up to that direction. Yes, we can put geosynthetics in some part if we need. When we work not on the water, so we can forget about the geosynthetics. So we can put like you wrap the soil and then compact the soil, and put another layer of the geosynthetics and do until up of this, and cover the surface of this compacted soil. So that's how we that's how we can make the water not penetrate into the soil. The most important thing, like you concern, this one. This is not easy thing to do because you cannot put a stop sign to the water. They will flow to any direction. So that's why we need to really understand about this. What is the soil just beneath this structure, and what is the hydraulic conductivity of the soil? So that we need to exercise more about this situation. And this situation is not, this is a common one, but sometimes it's only one spot, not all the way along there. So we need to sit and make and study about the soil, the site investigation and soil investigation, and then find the solution of it. Thank you.
So what you're saying?
Our system in here. If you have any question or discussion, let's.
How do you keep the water out of the ground? I've got people in Australia that do not believe we can keep the water out.
Okay.
And similarly, to stop the water getting in. So the thing that, when I talk to people that they have trouble understanding, is how the water can be kept out of the structure.
When they're working in the water.
Well, the two parts, when they're working in the water, but also when the water's, they just don't understand why it doesn't penetrate the groin or create a problem.
Okay, great. I think it's a very good point. This should be a skeptical question. Actually, yes, that's a great question because it's really technical one. The water is not protected like a waterproof, not like that one. So the water actually can be passed sometimes, or probably if you want to protect like a waterproof itself, it's probably can do that. But for the relief structure, we try to bring the water past the structure, because sometimes if the water, the main point is we don't want to bring the material inside of the structure will be out. That's the point. So if, let's say the water is like a transportation media, which means the water flow from this side to that side. It's normal, natural one. So if we put material inside, like put material on the river, and then we didn't expect to protect the water the flow of the water. So the water will be past the structure, hopefully up to, the inside of the structure will be passed as well by the water, but of course it's not like using velocity which is not quite fast enough, which is like a flood in the water. Which means, let's say make a simple one. So if using this one, the safety factor provided by this scenario, which is the load itself working, and then the water, the tide out will be there, and then
soil, and they will understand about this kind of problem. So we don't want failures anywhere for anyone.
But you have years of experience. Why would we go anywhere else?
During that time, even the owner said, "Why this has happened? Why this is?" And then we try to find the solution, and we through that thing.
One of the references that was made this morning is used, but one of the questions we had was if that material is so prolific around the world, and particularly in this part of the world, could that material be used in place of the concrete panels? That was the first question. The second one is, can other materials other than concrete be used for the panels, keeping in mind the economic factor? Graphene is one of the most prolific substances that is around, and one of the most strongest substances that are around. And graphene can be used as a compound with other materials that would also increase the rigidity of the panels and presumably increase the integrity of the panels.
Really intelligent technical wise regarding to the flow of the water. It's we call it compressible or incompressible, which is the water is really slow inside. This is not bringing a velocity to this structure. We didn't expect that one, which means the flood or the force of the water will be flood in our structure, not like that as well. Incompressible, which means the water leaking very slow, which means contain the structure and bring it so the structure will be sometimes happier than before. It's a good point. That's the point of here, what I've expected. But regarding to your question, how this material, for example, is the material bring us more protection, more protect with the corrosion. Of course, that's a good point for us because the corrosive environment will be degradation, mechanical degradation to our structure. That's a good point for us. We have to study, we have to calculate using this material, and the strength provided is probably better. We expect to use that one and in order to improve our. And another thing, if we change the concrete thing by using graphene, for example, graphene is really a strong material because my background in Manchester, which is the research center of the graphene prepping, actually, but today as a bulletproof actually for that one. Now it's not like that one. I think probably if you're using a polymer, probably it's better performance for this thing because the thing is the cheapest material we expect to use it here. It's a good point sometimes. It's in a developing country like this one. But of course, you said about advanced material, of course, really great material. And then if we get that one easily and then more cheaper than what we have, of course, we expect that one in order to provide better performance for the structure. Surely, we expect that one. First thing, as I said before, a polymer one. We didn't use that one at the moment. Probably next time, of course, you said about material like graphene, which really beyond our expectation that up to now. So next time, of course, that material is really incredible. So hopefully next time, yeah, surely.
We patented that one as well.
Great fun. In Australia, I'm very.
For those that want a cigarette and those that want to take the bathroom, so if we, and tea and coffee at the back. So if we take a quarter of an hour break, we'll just add one thing. I said the word spiritual before. What I should have said was it changes the view of the world, it changes the way we think and interact with the world, so the world view, and to working with natural forces rather than against them. So let's have a break.